In this video, we'll talk about finding inverses of functions and also what it means conceptually and graphically. So let's talk about the theory before we get too crazy into how to find them. So, what an inverse is, if we think about a regular function, you go from domain values to range values, and we usually denote it with an f of x. This function takes you from an x value to a y value, an input to an output. Well, an inverse takes you from a y value back to an x value. It undoes. And a notation, we use this little -1 here. So it's f to the -1 of x, or f inverse of x is how we say it. Now on a graph, what an inverse will look like. If we have our axis line, and we have the y equals x line, so it's that 45-degree line coming right through the origin, what's going to happen is if I have, say, f of x looks like this, well, f inverse of x is going to be reflected over the y equals x line. So what's close is going to be close. So it's going to look kind of like a mirrored version of it. So this is f inverse of x. And it would make sense because essentially what's happening, if you think about a t-chart, for f of x, say we've got 1, 2, 3, 7, whatever. If I have f inverse of x and a t-chart of that, I'm basically flipping the x and the y values. 2 goes to 1. So basically we put in a y and we get an x. 7 goes to 3. And it's that whole idea of you're flipping your domain and your range. Your range becomes your domain, and your domain becomes your new range. So let's put this into practice here. One of the first things we want to do with inverses is find inverses of functions. Some of them are pretty easy. Like in this case, I'm taking x plus 4. Well, I think what undoes addition to be subtraction. Now there's a cool kind of technique, because some of them are not as easy to determine, and I'll show it to you with this one to kind of give it some credence. So if I'm looking for the inverse, what I'm going to do first is, instead of writing it with this function notation, I'm going to rewrite it as an equation with x and y. Now, as we kind of mentioned before, with an inverse, we flip our x and our y values. So I'm going to literally flip x and y's positions in this equation. So x is going to equal y plus 4. Now the trick here, we've been drilled for years to solve for y. Get it all by itself. So we're going to do exactly that. And once I have y by itself, once I've made this switch, that'll be my inverse function. So I'm going to subtract 4 from both sides. So x minus 4 is equal to y, which tells me my inverse function, so f inverse of x, is x minus 4, as we kind of predicted in the beginning. Now let's take a look at another example. This one, it's not so clear. Do I divide by 2? Do I subtract 3? What do I do here? It's not quite so clear cut. But if I follow my technique, first thing I'm going to do, I'm going to write it as y equals 2 times x plus 3. Now I'm going to switch my x and my y's. So x is going to equal 2 times y plus 3. And now I got to get y by itself. So I'm thinking I'm going to divide both sides by 2. So x over 2, or 1/2 x if you prefer, equals y plus 3. And then I'm going to subtract 3. So y is going to equal x over 2 minus 3. And this would be our inverse for our original function. And that one, I don't know if I would have predicted in the beginning. So it's kind of a technique that we can use to calculate exactly what the inverse would be. Now there's more uses for inverses, and we'll talk about those in another video.